Hello students, welcome you all. In my today's lecture, I will explain the oxidation reactions of alcohol. Now in this lecture, I will tell you what are the main conditions for the oxidation of alcohol, what type of alcohol may undergo oxidation, what are the different oxidizing agents that we can use for the oxidation of alcohol, and what is the mechanism for the oxidation of alcohol. Now some of the features for the oxidation reaction of alcohols. So main features. So any alcohol which have the alpha hydrogen atom, it may undergo the oxidation. So but I can write this alcohol must have alpha hydrogen atom for its oxidation. Otherwise, it will not undergo the oxidation reaction. Now, another thing, during oxidation, we know, all of you know, during oxidation, the oxidation state increases. So here, as we are discussing the oxidation of this organic compound, so central atom is a carbon atom, so that's why the oxidation state of carbon atom here it will get increase. So during oxidation the oxidation state of carbon atom increases, and so we have a different definition for alcohol. Either the hydrogen is removed during the alcohol and oxygen get added. So we can also write during oxidation the hydrogen atom is removed. The hydrogen atom is removed, or we can say one of the alpha hydrogen atom is removed, and simultaneously oxygen atom is added there. Atom is added. Okay, and when you will see the mechanism of oxidation, then you will see during reaction this ester get formed. So, okay, so suppose if we are using chromic acid as oxidizing agent, then chromate ester is formed, and suppose if we are using the potassium dichromate, then magnet ester that will be formed. So during oxidation or during reaction chromate ester or this magnet ester get formed. Okay, so this is some of the features for the oxidation of alcohol. Now if you see, suppose if I am taking this primary alcohol, okay, so this is primary alcohol, and during oxidation what will happen? It would be converted into aldehyde. During oxidation that would be converted into aldehyde. Okay, so that would be converted into aldehyde. So how many carbon? 1, 2, 3 carbon. Here also 1, 2, 3 carbon. Okay. Now this aldehyde again it may get oxidized, and that would be converted into the acid. So this is from alcohol aldehyde is formed, and from aldehyde carboxylic acid is formed. Okay, so means alcohol get converted into carboxylic acid. So this is only possible when we are using a strong oxidizing agent. So suppose if you are using a strong oxidizing agent, then in presence of strong oxidizing agent, the primary alcohol that would be converted into carboxylic acid directly. Okay, first step, that is the aldehyde, then the carboxylic acid. So at last you will get the carboxylic acid. Now suppose if you are using the weak oxidizing agent, then the reaction will get stopped up to the formation of aldehyde. So this aldehyde would get formed when we use the weak oxidizing agent. Okay, some strong oxidizing agent, for example, this chromic acid. So usually this chromic acid, we use chromic acid, or we may use the KMnO4 in H plus H2SO4, or we can use K2CrO7 potassium dichromate in presence of H plus, so like this. Whereas the weak oxidizing agent, which stops the oxidation up to the aldehyde, so for example this pyridinium chlorochromate, or we may use the Collins reagent, or otherwise we may use Swern's reaction via Swern's reaction also, or otherwise we may use Des-Martin periodinone that can be used. So these are the different weak oxidizing agent, whereas chromic acid or this potassium dichromate in H2SO4 or potassium permanganate in H2SO4, these are the strong oxidizing agent. Okay, so now, so it means, suppose if we are using secondary alcohol, then this secondary alcohol that would be oxidized to ketone. Whereas if we have, because this, no doubt, what I have written here, alcohol must have alpha hydrogen atom for its oxidation. So if you will see here, then this is having 2 alpha hydrogen atom, this one, this is having 2 alpha hydrogen atom. So what I have told you, the alpha hydrogen atom is removed and simultaneously oxygen is added over here. So this is the alpha H atom, this is alpha hydrogen atom. Okay, this is the alpha hydrogen atom. Now, so that's why one alpha hydrogen atom is removed and we get aldehyde, another alpha hydrogen atom get removed and we get the carboxylic acid. Now here only one alpha hydrogen atom is present, only one alpha H is present. So the secondary alcohol, this gives the ketone. Whereas if we have a tertiary alcohol, suppose if we have a tertiary alcohol, so it will, since it does not have any alpha hydrogen atom, so it will not undergo oxidation. Now, so some of the strong oxidizing agent which can be used for the oxidation of alcohol. So if you will see this strong oxidizing agent, so either oxidizing agent may be strong oxidizing agent or it may be weak oxidizing agent. So one is the chromic acid. So chromic acid is used as a strong oxidizing agent, and this formula, that is H2CrO4. So this chromic acid is used as an oxidizing agent. So in place of this chromic acid, or usually we use this, suppose if you are using potassium or sodium dichromate in presence of this H2SO4 and H2O. So this gives the chromic acid. Finally, it gives the chromic acid. On this reaction, we get the chromic acid. In the same way, we may use this sodium chromate, Na2CrO4 in H2SO4, and this acetone, this may also be used as an oxidizing agent, or we may use this KMnO4 in H2SO4. Similarly, we may use potassium or this potassium dichromate in H2SO4, that may be used as a this reaction. Okay, so now some of the weak oxidizing agent. So if you see some weak oxidizing agent, So what I have written here, weak oxidizing agent, one of the famous reagent that we use as a weak oxidizing agent, that is the pyridinium chlorochromate. Pyridinium chlorochromate. So this is our pyridinium chlorochromate. So pyridinium chlorochromate, that can be used as an oxidizing agent, or otherwise we may use this Collins reagent, that is CrO3 in pyridine, that may be used, or we may use Tes-Martin periodinone. Next weak oxidizing agent, Swern's, in Swern's reaction, in Swern's reagent, or we can say Swern's reaction. So we use this oxalyl chloride in DMSO and triethylamine. So this oxalyl chloride, so this is an structure for this oxalyl chloride. So this, either this may be used. Okay, so these are some of the weak oxidizing agent which stops the oxidation up to here, aldehyde stage. Now if you will see here, then during oxidation, what I have told you, during oxidation, the oxidation state of carbon increases. Okay, so what is the oxidation state of carbon over here? At this is the central carbon atom. This is the central carbon atom over here. So what is the oxidation state of carbon over here? Okay, so if you will see here, the oxidation state of this carbon, it is -1. Here the oxidation state of carbon is -1. How it is coming? Okay, now here if you see the oxidation state of this carbon, then it would be this minus, here it is plus minus, and this would be yes. So this is -1 over here. Now here the oxidation state of carbon is +1. Oxidation state of carbon is +1. So how this oxidation state is coming? Okay, so let's see how we can find the oxidation, though we have some of the methods for the determination of oxidation state. But if you want to find, suppose if you want to find the oxidation state of carbon, so I am giving you the one of the very simple way that we can determine the oxidation state of any central atom. Okay, so suppose if we have So I am writing the carbon tetrachloride. If I am writing carbon tetrachloride, so all of you know the oxidation state of here, this carbon, this is +4. Oxidation state of carbon is +4. So how this +4 is coming? So one of the way of determining, so as all of you know, this chlorine being the more electronegative than this carbon, so this has the -1 charge, this has +1. In the same way, here also this is -1, this is +1, here this is -1, this is -1 and this having +1. In the same way, this chlorine having -1, this is having +1. Okay, so overall if you will see at carbon there is a 4 + 1 charge, so that's why the oxidation state is +4. Now in the same way, if you want to find the oxidation state of the CH4 over here, if you want to find the oxidation state of carbon in CH4, then we know that this carbon being the more electronegative in comparison to hydrogen. So carbon having the electronegativity of 2.5, hydrogen having the electronegativity of 2.2. So this is more electronegative, that's why it is having -1, it is having +1. So in the same way, this -1, this is having +1, this is again -1, this is having +1, this is -1, this is having +1. So overall if you will see, there are 4 -1 charges. So that's why the oxidation state of carbon, that would be -4. Now suppose if we have one of the oxygen OH is attached over here, and suppose for this one, so this is a CH3OH. So for this, what would be the oxidation state of this carbon over here? So in this case, if you will see, then carbon having if the bond between this CH bond, if you first of all see the CH bond, so this is more electronegative, this is less electronegative, +1, -1, -1, this +1, -1, +1, and now between this carbon and oxygen, oxygen being the more electronegative, it is having -1, this is having +1. So overall if you will see, 3 -1 charges and 1 +1 charge. So -3 + 1, so this comes out to be -2. Now, so again, if you will see this alcohol, suppose I have drawn this alcohol, and this is same thing. Okay, now this one, for this one, this is primary alcohol. This is primary alcohol. So in this case, here if you will see, this carbon is having -1, this is having +1, this is having -1, this is having +1. Now this carbon and carbon both having the same electronegativity, that's why it's 0, we can say no charge on anyone. And about this oxygen and this carbon, so oxygen having -1 being more electronegative, this is having +1. Now in the center, if you will see, there is 2 -1 charges and 1 +1 charge, so -2 + 1, so this comes out to be -1. So overall the charge is here -1. Now in the same way, if you want to find, suppose if you have aldehyde, I am having the aldehyde now. So in case of aldehyde, this is the central carbon atom, this is central carbon atom, from this carbon another carbon is attached, so same electronegativity, so no charge on anyone. Now in carbon hydrogen bond, this carbon is having -1 charge, this hydrogen is having +1 charge. Now here 2 bonds are present, 2 oxygen bonds are present, that's why on this oxygen it is having -2 charge, being more electronegative, this is having +2 charge. So on central carbon atom, if you will see, then overall charge that is present, that is -1 + 2, so this comes out to be +1. Okay. In the same way, if we have carboxylic acid, suppose if we have carboxylic acid, now here Now, so in carboxylic acid, what would be the charge over this carbon on the central carbon atom? So here this carbon-carbon, no electronegativity difference. Here on this carbon, it is having the charge of +1, where this oxygen being a more electronegative and having charge -1. Now for this bond, 2 bond, this is having -2 charge, this is having +2 charge. Okay, so that on central carbon, the overall charge, if you will see, +1 and +2, that is comes out to be +3 charge. So if the alcohol is oxidized, alcohol first of all, that would be oxidized to aldehyde, and from aldehyde it would be oxidized to carboxylic acid. So in this case, if you will see, during oxidation, what I have told, the oxidation state that increases. So here the oxidation state increases first from -1 to +1, and from +1 to +3. So like this, the oxidation state increases during the oxidation. Or otherwise, one of the hydrogen, as we can see, this is the alpha hydrogen atom. This alpha hydrogen atom, this has been replaced by this oxygen atom. And here again, one of this alpha hydrogen atom which is present over here is again, it is replaced by the oxygen. So during oxidation, oxidation state get increases, the oxidation state of carbon get increased, and the alpha hydrogen atom is being replaced by the oxygen atom during the oxidation. So suppose, that's why if there is no alpha hydrogen atom, then like the tertiary alcohol, it doesn't undergo the oxidation. So let's see some of the the mechanism for this oxidation. So what I told you, if we are using strong oxidizing agent, for example this chromic acid, if you are using the chromic acid, then the oxidation product, that would be the this acid, that would be primary alcohol that would be oxidized to the acid. So suppose, let's see the mechanism for this one. So if you is having this, suppose the alcohol is present, primary alcohol, and here this alpha H is present over here, this is alpha H. So in presence of this chromic acid, so that is H2CrO4. So H2CrO4, this lone pair of oxygen that will go into the d orbital of this chromium. So here this will pi bond that will break out, and what we may write here, now this oxygen having the plus charge, and this is now here chromium, and 2 OH group. This is one of the OH group, this is another OH group, like this. Okay, now we have, as I told, this chromic acid, and this, that is in presence of this H2SO4. This H2SO4, if we have H2SO4, that will in water, that will get ionized to H plus HSO4 minus, and this acts as this base. So this is the conjugate base of this. So this acts as a base over here, and this HSO4 that will take, okay, so this proton, and here this will form a double bond over here. Now this bond will get broken down and like this. So what we will get here, finally you will get one of the hydrogen, this is one of the hydrogen, and double bond between this carbon and oxygen is created over here. So like this, this is being converted into this aldehyde. So this is being converted into aldehyde, and what we have got, so we have got Cr, and this hydrogen, this again that would be protonated, either by this H plus. So this H plus will get protonate this one, and what you will get, you will get OH, and this is OH, and here you will have the minus charge over here. So this is, we have this H2CrO4. So here if you will see H2CrO4 minus, so if you will see here, then 8, 5 is having the +4 oxidation state, and finally this +4 that will be converted into +3. So overall, if you will see the this chromium which is having here this 4 and this how much? So this is having -2, -4, and this is having +6 charge. So that will be converted into this +3 charge. Okay, so like this. So this is the mechanism for this, where as you can see here, so this is the chromate ester which is formed over here. So after the removal of this H plus, if we remove this H plus, then here this chromate ester is formed. Okay, so here this chromate ester is formed. Now in the same way, we may write the mechanism with potassium dichromate also. Suppose if we have KMnO4 in H2SO4, okay, so here, so overall the charge over this Mn, that is +7, is the charge over this manganese, and now so this one, this will attack over here, and this pi bond that will break, and what you will get, we get the, in the same way we may write the mechanism. Okay, so and we will get the magnet ester over here. Okay, so we are having this magnet ester, and again this HSO4, that is this base, either this base may be this HS4 minus, or this water. Water may act as a base here, weak base, so it will take this one proton and it will form a double bond over here, and what you will get, you will get one of the hydrogen is present over here, and in the same way this one oxygen plus we will get okay one of this will get protonated by this H plus, so we are getting here H KMnO4 minus. Okay, so this we will get finally. So now after this aldehyde, so aldehyde that would now be converted into acid. So if we see the mechanism for this, how this aldehyde that is converted into this acid. So we have this water as a base, nucleophile, water as a nucleophile. So this will give here one of this O minus, and so finally this gives gem diol. So it gives the gem diol, or we can say it is also called as the hydrate. This is also called as the hydrate. Now in next step we have, suppose, chromic acid again. Okay, so okay, and now in next step, what we can write, we may write, because one of the this alpha H is still present over here. This is one of the H, alpha H of this one, this alpha H. So now this base, it will take this one, and finally we will get a double bond over here. So this is converted into acid, and we have this okay. So like this, the alcohol that is being converted into this acid finally. Now, in presence of pyridinium chlorochromate, as I told, pyridinium chlorochromate being the weak oxidizing agent, so that will stop the oxidation up to this aldehyde stage. So let's see the mechanism for the oxidation with pyridinium chlorochromate. So if we have, suppose, alcohol, then in presence of pyridinium chlorochromate, and in next step, one of this chlorine will leave out, being good leaving group, that will leave out, and we have and here we are having this alpha H, and again one of this base, either this HSO4 minus or this H2 act as a weak base, and it will take this proton, and this you will get here. So what we are getting over here, so we are getting H double bond OH plus and Cr. Okay, and so after losing this H plus, so that would be converted into aldehyde. Okay, so further this could not be oxidized, this pyridinium chlorochromate, after the removal of this this leaving group. So further oxidation of this is not possible over here. Okay, so this is the reaction, this is the mechanism for the oxidation. And so suppose if we have so what would be the oxidation, we may easily see. So in this case, so here this is the secondary alcohol. So this is a secondary alcohol. So either this may undergo oxidation either in presence of weak oxidizing agent or strong oxidizing agent. Suppose if we have, I have written KMnO4 and H2SO4, or if I am writing this chromic acid, or I am writing this, suppose PCC. So this will oxidize the secondary alcohol only to the ketone. Okay, and in this way we may see some more examples, and my next lecture I will discuss some of the examples related to the oxidation of alcohol. Okay, thank you.